Hello guys, welcome to the stream. So today's my stream layout is like a bit different because I was sitting on the chair since morning and now I was feeling back pain. So that's why today's live stream is going to be standing one. So I will not be using the other camera and it's already late. So now I will focus on my study. So I'm trying to implement this ANN. So this is the first time that I'm doing that deep learning implementation. Aman Mishra. Hello, bro. How are you? And today I'm not using my second monitor, so it is going to be a bit harder for me to read the chat simultaneously. So yeah. So what I'm going to do, I'm going to remove all these cells and I will write it again by my own feature scaling. Alright, so that's enough. So this was the installation we don't need anymore. So we have already installed company. What do you want to ask? I'm not able to see your complete message. Hello, Batman. Welcome back to the stream. It's been a while. If you are asking like in which company I'm doing job, so currently I'm not doing job anywhere. So currently I'm unemployed and just improving my skills and learning. So I'm learning machine learning, deep learning, and 3D modeling animation at the same time. So I do stream like 2 times in a day. So in afternoon, like I do this Blender theme, 3D modeling, and after that, like in the evening, I do this deep learning stream. Okay, so we are using 2.2 2.17. Yes, and in data preprocessing importing. So first of all, we need to import our data set. So this was the data set. So this is like a demo data set of a bank. We have to detect which employee will left the bank in coming days based on the previous data. So we have this customer ID, surname, credit score, geography, gender, age, tenure, like since how many years he's has his account in this bank. So this bank is belongs to Europe. This is the balance, number of products like ATM, debit card, etc., or other service. Has CR card holder, that means credit card holder or not, is active member, uh, like uh, has he been like using the service in last couple of months or weeks. So it means if he was using the service of bank, so it means like it's active member. And this is the estimated salary based on their profession. And yes, so we have to get some information from this data. Try GANs, VAE. Uh, I will learn GAN and other things. So yeah, but after clearing the basics, could you please explain what is happening in the code? I also started to learn neural networks. I am not expert in explaining, so I am just learning and writing code. And the main goal of this stream is to like focus and be consistent. Yeah, he's just preparing the data. Okay, thanks. Yes, so we just need to import data. So before learning like a machine learning, I spent a couple of weeks learning these basic libraries. Like these libraries are essential for learning ML and deep learning, NumPy pandas. So they help a lot in pre-processing. And another library is that matplotlib. So it help a lot in visualizing the data. So we need to import this churn modeling.csv. Do we have header? Yes, we have header this. Okay, and let's print the first 5 rows. So yes, so data is imported. By the way, like I'm following a tutorial on Udemy and simultaneously implementing it. So I'm just following a tutorial and trying to implement. Labeling, coding the so yeah. So like every machine learning, deep learning model work only on numeric data. So in pre-processing, what we need to do, so we will be using only those columns which are valuable to us. Like we don't want, so customer ID is not going to contribute anything. Surname is also not going to contribute because computer can't uh, categorize human being based on their religion, caste, or gender. So we need only this data. Credit score, so it is numeric. So these two columns are not in numeric, the geography and this gender. So we need to import them into numeric data first. So yeah. So first of all, let's before encoding, I think we should um, uh, I think we should separate this our X and Y. What do we call X? Y is the target and X is like features, no? So PD dot I log means index location, and we will be using all the rows. and then column 0, 1, 2. So we will be using from 3 onwards, and then -1 because we don't want this last column in our text. So if I print this, that's dot head. So yes, we have credit score, geography, gender, age, gender. So yes, we got all of these. And in Y, we will be using pd.ilog all the rows and then last column only. So that is going to be uh, this exited or not. Yes, so now we can do this encoding, label encoding the gender column. So, okay, so we will be using label encoding for gender column and one hot encoding for geography column. Uh, Let me read more about this. Like, what is the difference between label encoding and one hot encoding? I don't remember exactly, but I am sure like a label encoding is just it is going to use 0 1 combination, I guess, for gender. So it is like very basic because we don't have a lot of variety in this. So we have only two categories, male and female. And in one hot encoding, so we have different countries of Europe, France, Spain, Italy, and other thing. How many countries we have? France, Spain, Germany, France, Spain, Germany, only three countries. Is this in data from only three countries? Yes, so there are only three countries, I guess. I think I can see data like this x dot info. So this way we don't get this information. How do we get describe? So describe is going to tell us that standard deviation and other thing. So via this we can check like how data is distributed, and we need to use standard deviation. Sorry, that after encoding, we need to do feature scaling also because like the values are very different. So we need to scale all of them into single thing. Okay, let me search more about this one hot and other thing. Is this a classification problem? Uh, 0, 1. Yes, this is the classification problem. So this is not regression because we don't have like continuous data here. So we are just classifying. Yes. So this is a type of binary classification problem. So we are predicting two possible outcomes. So either the person will stay or the person will leave the company. This way. And I was also wondering, like, is this supervised or unsupervised? So, like, we have this in ANN, in this data set also, exited or not. So we have this column uh, which we can use to predict and compare. After prediction, we can compare with the actual outcome. So it means like we this is supervised ANN, and ANN can also be used for unsupervised as well. But I don't know as far now, so far now, like how it is going to calculate that the loss function. Okay, so label encoding is just like assigning values like 0, 1, 2. So if we have like temperature, low, medium, high, we can just assign 0, 1, 2. But the issue with this label encoding is uh, model will assume like if there is a sequence in this pattern. So because we are using 0, 1, 2. But in one hot encoding, what happens? It convert it into like a binary number system. And like I guess it to store it in byte. One hot encoding create a new binary column 0 or 1 for each unique category. Only the column corresponding to the specific category will have 1, while others will have 0. So I guess it's obvious like if we have more than two uh, like categories in a single column, so then we can use this one hot encoding. How many types of encoding are there? Okay, so there is label encoding, one hot encoding, ordinal encoding, binary encoding, frequency encoding, target, hash encoding, leave one out, count encoding, polynomial, cat boost. So there are a lot of encodings. Okay, so in one hot encoding, it creates a binary column for each category. Okay, so it means like in this we have these categories: France, Spain, Germany. So it is going to create a three columns: France, Spain, Germany, and in each column, like for example, it creates Germany. So it is going to put one, and those values for values do not have like this Germany, that is going to put zero. Okay, we need to import from sklearn. Is it in preprocessor? Yes, sklearn. Yes, it is in preprocessor. Okay, so we need to create the object of this class label encoder and then fit. So let's use in the convention and then value dot fit. So we want to fit this gender column and let's see. So in X, like let me do this. So 0, 1, 2, 22nd one. I did something wrong. Oh, zeros in second column. We are getting now. Slice none, none, two. Okay. And what is the difference? Like in some of the code, I see. So they use these values. I guess if I use here dot values, okay, numpy and the array object has no attribute dot head. So okay, so dot value converted into numpy array. Otherwise, like if we check the type of x, so it's numpy and the array. If we use it like this, it is going to be data frame. Yes, so it is a data frame. Okay, so that is the difference. So we need to pass this n-dimensional array here. So that was the reason they are using dot values. And after converting that to dot values and the array, we can print it without this inode. So inode is no longer going to work because it is not a data frame anymore. Okay, so this is how it is working. All right. So fit, I guess we can directly use fit transform instead of this, but like a fit transform return and the array. So we need to update the same x value, same column, uh, like this, and it dot fit transform. So here we can just do it like this. So if we show this now, okay, so let's see the first row and all columns. So we can see 619 France and then 0. So it assigned 0 for this France. Sorry for gender, it's for gender. 0 for female. All numbers. Let's see value of number 6. So yes, it is okay. So this was our label encoding for the render column, and here we are going to use one hot encoding from sklearn dot preprocessing import. Yes, it is there one hot encoder. So then we are going to create object of this class. What is the naming convention for this? So the naming convention is used E and C in code. Okay, so this is also going to be same encode dot transform, I guess. So here we need to pass x, y then is y. X is array shape, input sample, array like of shape, target values. Why this need this y one hot encoder? Wait a second. Uh, I don't think so. It is done like this. One foreign boundary is passed as like so to apply one hot encoding, we also need a column transformer. But what is the need? Why do we need that column transformer? We often use column transfer when applying one-hot encoding or any other reprocessing technique because it allows us to handle multiple types of data at once. Our dataset often contain both categorical and numerical features. While one-hot encoding is needed for categorical columns, numerical columns might require scaling or other transformation. The column transformer help apply different transformation to different columns in a single streamlined process. Okay, so selective encoding. Instead of applying one hot encoding to all columns, you can specify which column to encode and which to leave untouched. So it means we can apply with this column transformer, uh, like we can apply encoding to multiple columns at the same time. So here they're applying to cat and okay, so for cat, uh, this is cat, yes, it is a column. Assume column 0, 1 are categorical and column 2, 3 are numerical. Okay, okay. So CAT means categorical and this UM means numerical. And 0, 1 is categorical and 2, 3 is numerical. So we are applying one hot encoding on 0, 1 and the standard scalar on 2 and 3. What is this pipeline? Preprocessor in a pipeline. Preprocessor plus eval. The categorical columns are one hot in quadrant. The numerical columns are scaled within standard scalar. The processed data is fed into logistic regression. Okay, so it means we can do this label encoder and one hot encoder in a single step using column transformer. City control column transformer, and here we can use transformer, remainder, sparse value of transformer weight. Okay, in transformer parameter, we will list of name transformer columns. Suppose specify the transform object. So we need to specify our transformer in a tuple, list of tuples. So in tuple we need to pass name, transformer, and columns. So name is going to be string, like in pipeline, and feature union. This allows the transformer and its parameter to be set using set terms and searched in grid search. So in name, what we need to pass? Encoder. So a transformer, a metal column transformer is a list of tuple where each tuple specifies the transformation to be applied, the transformer itself, and the columns on which to apply the transformation. Each tuple is in the transformer list and has the following format. Name. Okay, so we can name anything, I guess. A string that represents the name of a transformation step. But why it is necessary? Do we use it for other things? This is just an identifier and can be anything. Example, one hot scalar, etc. Can I name it? Veer, useful referencing and debugging. Okay, okay, so we'll name this uh, hot encoder, and then we need to specify our transformer object, the actual transformation or pre-processing method you want to apply. So this can be any transformer that implements the dot fit. Okay, so we can pass here label encoder, standard encoder, one hot encoder, min-max scaler. Okay, so we want that one hot encoder here. So we imported one hot encoder as the function, and then we need to pass the columns, which column we want to encode. 0, 1, 2, 3. So here I need to pass like X, all the rows and column number 3, 3, no, or 1, 1, 0, where is it? So this is our first 0, 1. Okay, so we need to pass 1 here. Okay, so our transformer is complete, and what next? Remainder. What is remainder? Drop pass through or estimator. Default is drop. By default, only the specified column in transformers are transformed and combined in the output, and the non-specified column are dropped. We don't want to drop other, but we specified here like we this only one column. So is it going to drop the other columns if we use drop? By specifying remainder paths to all remaining columns that were not specified in transformer but present in the data passed to fit will automatically pass through. Okay, so we will use this path through instead of that. AINDER. Let's try what happened if we pass drop. What other thing we need to pass? Sparse threshold 0.3 n jobs. None transformer revealed was. I guess that's sufficient. We need not to pass any other thing, I guess. Okay, so let's see what happened. If I check this out now, Nothing happened. I guess we have not applied that transformation. After this, we need to apply fit transform. CT dot fit. Fit transform is going to return something. Column transformer. Okay, so if we pass only fit or transform using X, uh, self column transformer, do we need to still pass this X? I guess I need to pass on the X, like all the columns, and then it is going to change this and will drop the rest of the columns, I guess. We got an error. One hot encoder object is not iterable. Why we got this error? Okay, so we need not to pass it like X. So as we are just passing here X, and here we need to specify which column. We need not to specify again the variable name. Let's see it now. Still getting error. Not encoder is not iterable. Let me run it. Oh, yeah. Still getting same error. We didn't pass it like this. Okay, so it is not only a tuple, it's list of tuple. So we need to pass this. Okay, so it's list of tuple. Minor mistake, big impact. Hmm. Okay, so this is how we can debug fault encoder. So this is the name we are getting here. Okay, so let's see the things I wanted to see next. Okay, so till now it is just a bit we need to transform. These are the parameters. Let's see attributes, transformers, sparse, output indexes. So this is collection of vector transformers. Yes, that is vector transform. So here in output only gave us uh, encoded result. So if we drop other this we need to use pass through. So now we are getting our other results. Yes, that is the difference. Till now we have not finished our preprocessing. It's 1 hour 15 minutes. That's what happens when you keep watching the tutorials and don't implement. I'm implementing it after a long time. Let's store it in Excel. cp.fit transform. So let's convert it into the array. Did we import a number? Yes. And the array, let's convert it. So this is our X now. So if we see the zeroth row and or the columns. So, one hot encoder is using different column for each category of that what was the category country. So this is one for Germany. What other countries were there? France, Germany, France, Spain. So this is for Germany, France, and Spain. And then 619 is credits for, zero is male. Oh, sorry, zero is female, and then other categories. 42 to 42 to 011. Yes. Alright, so our encoding is done. So next thing is we need to apply train test split. So from sklearn dot models selection import train test split. So here we need train x train. Okay, so we this is the notation for such variables. X train, X test, Y train, Y test, then train test split. Here we need to pass our array, X and Y, and then test size. We will keep it 0.3. We have good amount of data. Or let's use 25% as testing and rest of for planning. And random state, let's use some random number. Let's use 45. Shuffle true or false. Whether or not to shuffle the data before splitting. Yes, we will shuffle. A random state instance or none. Default none. Control the shuffling applied to the data before applying. Okay. Okay, so that's it. Y is not defined. Y is not defined. Okay, so it's capital Y. Let's see how our data looks like. X train and Y train. Let's check their size. Let's So our Y train is 7500 and the Y test 2500. So total we have 10,000 rows. So after line splitting data, we need to do feature scaling. How do we scale features? Okay, so yes, we need to apply standardization. Here we use that our standardization. So X is like our input. This mu is our mean, and this sigma is the standard deviation. Standard deviation is calculated. How do we calculate? I forgot. What was the formula? Okay, so this is like input minus this mean. Yes, so like for like we have one column, so we calculate the mean of all the numerics, and once that is calculated, we pick individual element of that column and then subtract it from this mean. And after doing all of this, we scale them and then we sum all of them and then divide by total number of n elements. Okay, so let's apply standardization. Where do we use standardization? Standardization can features to have zero, mean, and unit variance. This method is useful when the distribution of data is Gaussian or normal distribution. Okay, so first of all, yes, we need to plot the graph and see what type of distribution we have in our data. And only then we can apply this standardization. Min-max scaling. The method scale the feature to a fixed range, usually 0 to 1 or -1 to 1. It's useful when you want to want the features to have a specific range, or when the data does not follow a normal distribution, that is Gaussian distribution. Okay, so in those cases we can apply this min-max scaler. Max absolute scaling is useful when data is already centered around 0 or 4 sparse data. Robust scaling, instead of using the mean and standard deviation, it uses the median and interquartile range. That interquartile range is like 68% falling like this center, and then L2 normalization. This is useful when the magnitude of vectors is more important than the actual values, such as in text classification or clustering. And the magnitude of factor is more important. Okay, so now we need to check what type of data distribution we have. We can check it here uh, using x.describe if we don't want to use we need to run it from here again. Okay, so dot values. Sorry, I mistake. We can just do pd dot describe. So this is the 25%, 50%, 75. Can we estimate it from here? But then how we will we need to create the chart between age of credit score. How can I check what was this spelling whether WEATSER or whether so WH. WHTHER DIS learning English at the same time. We can use histogram. Histogram is good, but we need to apply it for all the columns. Especially when you have multiple columns, you can use combination of visualization and statistical tests. Plot compare the quantiles of your data to quantiles of normal distribution. Box plot. This is pixel size. This is box plot. Here is our x. Uh, X equal to data frame dot column. We can cross x and then column. Uh, I'm not able to understand. Like, do I need to check for all these columns? Like, how is data distributed? Hmm. Okay, so we are plotting histogram for all the columns by using for loop. Then I can just pass a column. Hmm. TF modified there. Okay. X. Numpy and their inject does not use columns. Must be integer. Uh, it's happening because of this. So here we will pass only all zeros and column 0, 1, 0, 1, 2. Let's pass from 3. Unable to pass the string pass at position 1. So TQ. What is the issue? Everything is in numeric, isn't it? why I'm doing like this. Then I need to pass only headers like this. So we can do this indexes. Hmm. Yes, now we got what we wanted. So our age is distributed in normal distribution. Tenure is not normally distributed. Histogram of balance is normally distributed, except like we have an outline here. Is this? No, it's not outline. Like a lot of customers, like this is a histogram. So like there are 3,500, 3,500 customers have zero balance. This means that, and only 1,000 customers are there whose bank balance is above. How much is this? 1 crore? No, it's 1 lakh. So only 1,000 customers are there whose bank balance is like 1 lakh, and 3,500 customers have zero. 7,000 customers have credit card and 3,000 customers don't have credit card. Active member. So 5,000. It's like 50-50, isn't it? Like 48,000, sorry, 4,800 has like they are not active member and rest of them are active. Histogram of estimated salary. So uh, salary is like almost same. And how many customer exited? Only 2,000 exited the bank and rest of them are here posted. I guess we can use the Gaussian that standardization. So normal distribution we can use because our data is normally distributed in case of balance, but and age. But how can I guess? How can I assume like which column is more significant than other? Like only two columns are there which are normally distributed. The one is age. I guess age is good factor, but in machine learning and deep learning, so we don't assume, we talk based on facts. But like how machine will know without the human intervention? Like that feature is important one or not. So we need to find the correlation. Okay, so let me do one more thing. So we will apply this after encoding so that we can know uh, how the data is distributed for uh, those two columns, gender and what was the other, country. After one hot encoding and this. So we will be doing visualization. But here is the issue. We need to mask it like in numeric forms. Let me watch the video, how they have done, what type of. Hmm. So we need to do correlation analysis for this to determine the significance of importance of different column in your dataset, especially when dealing with both continuous and categorical features. You can apply various techniques to assess their contribution to the target variable. Example, unsettled in your case, which indicates whether the customer will close the bank account. Here are few methods you can use. Correlation analysis. Okay, so need to find the correlation between exited and the rest of the features we have. For continuous variables, you can use correlation to see how strongly each feature is related to the target variable. Is the stream going good? Time is slow. The music is not playing. Okay, so let's take a break. Otherwise, I guess this is the first time I'm streaming from the front camera with full view. Is anyone here? Uh, Shaheen, tell me Veer, what is AI? I guess I told you yesterday or day before yesterday. You asked me like uh, the interviewer asked you question. What is AI? Shaheen, from which state are you? No, I was trying to see what you were going to say. I didn't think you remember me well. So, from which state do you belong? Oh shit, I forgot. Yesterday, one of the viewer asked me to contact him on Instagram. I forgot. Shaheen, tell me more about yourself. Okay, so no one is here. Okay, so let me resume. So I'm not going to in depth. So I spent a lot of time here. So let me just quickly um, complete this and move forward. So initially we need not to perfect everything. So yes, so let's apply Veer's theory. So we need to scale on our training data and test data. And we need not to apply like fix the model again and again. Like here it trained the model on this standard scalar and then transformed. And later we need to apply only transformation. Otherwise, we can split into three steps. Like first of all, we can apply scalar dot fit, and then we can apply scalar dot transform on x train and then x test. But like we trained on this training column only, and then applying the transformation uh, for the training and testing both. So if we print them now, express, let's try express. So this is how it fitted the data. So here is our three columns. First three columns like countries, then credit score, then rest of the columns. So if we check the length, so we have 12 columns. But if we check our previous data, we have only 10. It means it added only two columns. Okay, so it added two new columns because the third column can be predicted using the two columns. Like in this country column, we had only three categories: France, Spain, and Germany. So like it considered only two, France and Germany, and the third one will automatically be identifiable. So yes, that's what is done here. That's why it has length 12. Okay, so next is the new concept that I don't know yet. So here we are going to fuse in and 70% work is done. So currently I'm watching a tutorial. I can't stream that tutorial because that is Udemy course, so it will show only black screen. So I'm watching the tutorial and then I will start implementing. So I will try to implement it in both using TensorFlow and PyTorch, and we'll see how much is difference between both of them. So we'll get some introduction to this TensorFlow library and like how many classes are there for everything. Hello, hello. Um, Tesla YT. Bro, can you please tell me what all are the resources for learning, like YouTube channel, courses, etc. Right now, I am like learning from Udemy course, YouTube course, videos. Let me share you the links. So I'm following Udemy course. Where is it? This is it. So I'm following this Udemy course, A to Z machine learning. Other than that, I'm following, if you know Hindi, so then this is my friend's channel. He is like my classmate. He has 19,000 subscribers on this channel and half a million subscribers on other channel. So like he know machine learning, deep learning well. So here it is. You can check his channel. So he has provided, if you know him, like he has provided very good uh, videos on machine learning and deep learning. Other than that, you can follow Krishna's YouTube channel. So like I'm following only these resources so far. My laptop is very slow. I don't know, released new video. You can check this channel. Welcome, welcome. Any other thing you want to ask? Alright, so let's start with the hello world program of TensorFlow. So far, like we did pre-processing. So now it's the time to start with this ANN. So I was just getting some overview. You have course from Code Basics. Yes, uh, Code Basics. Like I just followed machine learning, but that is just like an overview, you can say. But yeah, I followed that course also, but not following at the moment. I just followed that ML. He has not covered all the things. I don't know about deep learning, whether he has covered. I guess yeah, he has covered. He has videos on YouTube as well on deep learning TensorFlow. You can follow that also. But right now I didn't post those videos. But I found Krishnak's channel like very helpful. So he went in depth, like explaining the mathematical set. So you can follow that for sure. And the Udemy course I'm following uh, is because it is a comprehensive course. So it has everything from machine learning to uh, NLP, ANN, deep learning. So in that course, like everything uh, is covered, but not in depth. So it's just an overview. If you want to really go in depth after following these uh, uh, courses, you can follow NG's course on Coursera. So that's the like at high levels. My friend suggested me to cover the basics first. Like uh, he suggested me that like don't go in depth in the beginning, otherwise you will be exhausted. So he suggested me to complete that Udemy course first and then move toward Andrew and this course. But I'm not going to. Uh, I'm not sure. Like I will do that Andrew and this course or not. But it is going to take a lot of time because it is very much in detail. Uh, but for now, like my goal is to start with this TensorFlow and PyTorch thing and start building some projects. So you need not to devote too much time on mathematics and at the same time go in depth. So just keep it like that, like you don't get burnout and you feel these things interesting. So keep it at like that. All right. Okay, so this is the hello world program of TensorFlow. A sequential model is appropriate for a plain stack of layers, where each layer has exactly one input tensor and one output tensor. Okay, Sequential group a linear stack of layer into a model. Okay, so this is like a kind of layer we are adding. This is the shape and then the input layer. Okay, so sequential is like a wrapper and it has functions which we will be using to add input and hidden layers. The sequential model is appropriate for planes type of layer. Okay, where each layer has exactly one input tensor and one output tensor. Schematically, the following sequential models. So in sequential model, we are taking dense layer. So this is layer 1, this is layer 2, using activation as value rectified tensor unit. Rectified rectified linear unit, what was it? No, rectified linear unit. So it ranges from 0 to like infinity with maximum. We take maximum from 0 to infinity between values. So let's see. Then we need to pass unit activation use files. What is unit? Complement the dimensionality of output strings. This sequential neural network is like a forward propagation. So let me see some images of this sequential neural network. All right, guys. So it's already 11 p.m. So I have to go to sleep now. So I will continue implementing tomorrow. So we are left with this implementing TensorFlow. Uh, like it is simple thing, but I need to get uh, to know like what is the meaning of all these things, what is sequential model, and what are the input and these tensors. Layers. So I will read more about this tomorrow. Today we did pre-processing and just revise the previous concepts of machine learning. So that's all, and thank you so much to join today. Aman Mishra, Batman, Shaheen, Texla, YT, and all other who joined but didn't comment. Thank you so much. So yeah, I will see you all tomorrow. And in Blender today, I just added some fields, built some basic projects, added values to the object, and learned few tools like snapping and other thing. And I built this table and chair. I was building the chair, so I will continue tomorrow. So yeah, let's go. Bye bye.